Alright, this is going to be a video answer for page 58, number 7, by request from one of your peers, a classmate. I hope it helps more people, just not just one. It is part of the homeworks, and I know it could be a little bit of a struggle, but after this explanation, I hope it will be a little more clear to you. The question says, a soccer ball is kicked from the ground after traveling a horizontal distance of 35 meters. It just passes over a 1.5-meter tall fence before hitting the ground 37 meters from where it is kicked. Now, the picture also gives you a kind of a diagram, but I'll make some additions to it. There's a ball. Here is the ground. It is going to be kicked in the pathway that it is kicked is going to be a parabolic pathway. It says that the distance from the start location to the end location where it lands is 37 meters. It also says there is a fence just grazing, sort of just underneath the ball's trajectory. It is 1.5 meters tall, and that is a distance of 35 meters from the fence. Okay, so this question is provides for you. Part A, it asks for the equation of this parabolic pathway, but it gives you some pointers. It says, pretend the ground is the x-axis. Great. And pretend where the vertex is supposed to be, right down the middle, is a y-axis. Okay, great. That actually helps us a lot if you didn't catch that, and you'll see why. Let's see. From our class on chapter 1.6, you may remember that anytime you are given a kind of graph or anything parabolic, and you are asked to create an equation that models this movement parabolic shape, there are two ways you can do it. You can either use information given for the two roots plus an extra anchor point. Any random point that they give you, that is enough information to get an equation. Another one is if they happen to give you the vertex, all you need is one more point, and you can calculate the equation. In this particular scenario, notice that they suggest putting the y-axis where the vertex is, which means, along with the x-axis, the point where the ball begins and the point where the ball lands essentially is going to be my x-intercepts, which are equal distance to where the vertex is. Remember, the vertex is also where we would have the axis of symmetry. In other words, from one x-intercept to the other, they have to be mirror image. They have to be equal distance from the y-axis, or from the vertex, sorry. Okay, so let me clear this up just a little bit. I'm going to erase this. I don't need the 35 meters right now. I just want to focus on the 37. Remember, the distance from the start of the ball and where the ball lands is 37 meters. And if this is supposed to be equal distant from the y-axis, then essentially we can take 37 and divide it by 2 to give you the distances here. So I'm going to do that. 37 divided by 2 is 18.5 meters. And since this is the y-axis, to the left, I am going to give the starting position of the ball a coordinate negative 18.5 and 0, the landing position to be positive 18.5 and 0. All right? And then if that is the case, all right, let me erase this for a second because I need some space. Please remember the question also said that from the start of the ball to the fence is 35 meters. But from my division of 2, I know that the distance to the y-axis is 18.5. So I can actually find out what that remaining piece is. Let me just do some quick math. 35 minus 18.5 will give me 16.5 meters. This is 16.5 meters. Why does this help me? Then take a look. If the distance from the y-axis to the fence is 16.5. The x value would be 16.5. And if the height of the fence is given as 1.5, then essentially that point right there where the ball is supposed to just pass over the fence, you can deduce or you can assume that that location is going to be on the parabola with a coordinate of x value 16.5 and a y value 1.5. It corresponds with the horizontal distance from the vertex, and the height of the fence will correspond with the y value. Okay? This is all important because if I have a point here and I have these points here, I have essentially an x-axis, x-intercept, and I have a random point. So I don't have the vertex, but it doesn't matter. I can go this route and get myself an equation. So let's do that. Knowing that I have two routes, I am going to use the x-intercept form to help me. Let's see. I know that my x-intercepts are going to be a negative 18.5, a positive 18.5, and my random point when the x value is 16.5, I'm going to plug in, and the x value is 16.5, I'm going to plug in. The y value must be 1.5. And this is necessary, as you know, so that we can find the a value. Then we have the entire function. So I'm going to solve. 16.5 plus 18.5, 34, 35. 16.5 minus 18.5, negative 2. A times negative 7, that means A is 1.5 over negative 70, which can be rewritten as 3 over negative 140, just to get rid of the decimal. All right? And I don't think that's going to be divisible by 3, so I can't reduce it any further. My final formula, and this is for part A, is negative 3 over 140 x plus 18.5 x minus 18.5. Done. Hope that was useful. Let's go a little bit further and solve B. B says determine the maximum height of the ball. In other words, what's the vertex? Well, that's actually quite easy. I can use the formula or the equation that I just discovered. I know that the vertex, as the question suggests, is on the y-axis, which means automatically the x value of the vertex is going to be 0. So another way of asking what's the maximum height is like saying, what's the height when x is equal to 0? So you plug that in. 0 plus 18.5, 0 minus 18.5. Multiply it through. Let's just do it all at once on the calculator. If I had it open with me, looks like it is approximately 7.3. I'm going to double check. Times 3 divided by, yes. 7.3339. I'm just going to round it to one decimal place for now. Approximately 7.3 meters high. Part C. How far has the ball traveled horizontally to reach the maximum height? I think we already solved that. Right? From the point where the ball is kicked to the y-axis, we've already established is a distance of 18.5 meters. Right? And therefore, because the axis of symmetry and because the vertex is located on this vertical line, the horizontal distance is 18.5 meters. The ball travels a horizontal distance of 18.5 before it reaches maximum height. Part D. Develop a new equation for the quadratic function that represents the height of the ball, considering the ball has been kicked from the origin. That's a little bit annoying. Here, I'm going to erase some of this stuff. What they're trying to say is, all these points are important and all, The x-axis doesn't change, okay? And the fence doesn't move either. But what they're saying is the y-axis is no longer, oopsies, there. The y-axis is going to be where the ball was kicked. This way, it makes sense for the ball to say that it was kicked from the origin 0, 0. How does that change things? Well, it doesn't change much. It only changes the point, the xy ordered pairs that we're going to use for the equation. Before, our points were negative 18.50 and 18.50 with a random, I guess, accuracy point of that. This time, since we're kicking from the origin, a horizontal distance of 37 meters means my next x-axis, x-intercept is going to be 37 and 0. That also tells me automatically that the axis of symmetry is going to be at 18.5, which is halfway to 37. And this accuracy point, which used to be 16.5, is no longer 16.5. We can use the numbers that the question gave us already. The question said that the ball travels, if it traveled 35 meters, it would approach this fence. The fence is 35 meters from the place it was kicked. How high is the fence? That doesn't change, that's 1.5. So instead of 16.5, this accuracy point is now 35, 1.5. So once again, the points that we use, the x-axis, the x-intercept, and the random accuracy point will change, and so our equation will be a little bit different, but how we do the math will be exactly the same. Okay, so you can think about the equation, try to calculate it yourself, and I think you can be pretty confident in what you calculate using this part A as a template. Part E says, outline the similarities and differences between the functions found in parts A and B. Well, you will need to calculate this first. I think we already identified the differences. For example, the x-intercepts, the location of the vertex, and the coordinate for the fence. All of these are different, but there is one aspect that is going to be the same. See if you can find that. Part F says use a graphing calculator to check your answer and whatnot. You don't need a graphing calculator. I highly recommend using Desmos.com. It's very user-friendly. Punch in both of your equations to see if you have the same one. Then you know that you have the same description. It's just you will see that the x-axis and the y-axis might be a little bit different. I'm hoping this is up to your expectations. If you still have some questions, when I post this video on our classroom, just add some questions and stuff into the comment section below, and then I'll get an email notification from the Google Classroom telling me that someone posted, and I'll come right back to it. Okay. Hope this is efficient. If not, once again, reach out. Thanks for asking this question, and I'll see you soon.